Okay, this is the Chapter 3 group quiz, the free response questions. So since we didn't get to go over them in class in 5th period, I'm going to go ahead and try to explain each one really quick to help you guys out. So number 11, a certain psychologist counsels people who are getting divorced. A random sample of 10 of her patients provided the data in the following scatter plot, where X is equal to the number of years of courtship before marriage and Y is equal to the number of years of marriage before divorce. Describe what the scatter plot reveals about the relationship between length of courtship and length of marriage. So just looking at it overall, you can kind of see that it does appear to be somewhat linear, maybe not very strong because the points are kind of scattered a bit, but there does seem to be a linear relationship and it does seem to have a positive slope, which tells us as your length of courtship is longer, then your length of marriage is also predicted to be longer as well. So the answer that the answer key gives is there appears to be a moderately strong positive linear relationship between length of courtship and length of marriage. Okay, again, it's moderately strong, not just strong, because it is kind of weak. The points are spread about a bit. They're not really on, a single straight line. They are kind of away from the point a bit. And so it's not, a correlation value of like 0.9 or something. It might be like a 0.7, 0.8, something like that. So it's not quite as strong as we would maybe want it to be. So there appears to be a moderately strong positive linear relationship. And again, we get positive because we have a positive slope. Sorry about that. Positive linear relationship. And then we want to bring back the context of the problem. And so it's between the two variables. So we want to say between the length of courtship or of years of courtship. Just say length of courtship and length of marriage. Okay, part A is done. Let's go on to part B. Part B says, suppose a new point at 4.5, 8, that is the years of courtship would be 4.5, years of marriage would be 8, were added to the plot. So we have 4.5 about right here, 8 would fall about right here. So we're looking at a point about right there. Okay, what effect, if any, will this new point have on the correlation between courtship duration and marriage duration? Explain. So that point that we've added to the scatter plot is even further away from all the data. So it's actually going to weaken our correlation. It's going to get closer to 0. So they say the correlation would decrease . You could say it's getting closer to 0. It's closer to 0 because remember, the closer it gets to 0, the weaker it is. And why is that happening? It's happening since the point is away from the other points. Since the added point, just kind of putting it in my own words, is away from the data. It will weaken the linear relationship. Sorry guys, drives me crazy that it just clicks onto the next slide just from dotting I's and crossing T's. It will weaken the linear relationship. Okay, moving on. So then they give us a computer printout, and it says, what is the slope of the regression line? Interpret the slope in the context of this problem. The first thing you need to go find from your computer printout, I know you need the slope, but you're not going to have the word slope in your computer printout. So you're going to have to go find the y-intercept first, and the y-intercept is always going to be next to the word constant or the word intercept. Okay, so you will sometimes also see the word intercept instead of constant. Constant or intercept gives you the y-intercept. The number below it is always going to be your slope. So our slope in the problem is 2.4559. Okay, that is our slope. But they say interpret the slope. So what I would like to see you do when you're interpreting is take your slope and always put that number over 1. Okay, so we have 2.4559 over 1, and I want you to remember that it's always change in y over change in x. That's just going to help you write your sentence correctly. So we're going to start with the x, and we're going to say for each, I'll say year increase, for each year increase in what? In our x variable. So what was our x variable? Our x variable was the length of your courtship. So for each year increase in courtship, there is a predicted, and we have to figure out, is it an increase or decrease in the y? So we're going to say it's an increase if we have a positive slope. It's going to be a decrease if we have a negative slope. So there is a predicted increase since we have a positive slope of how many years? 2.4559 years of marriage. Okay, I can promise you on your test, there's going to be another question, which is not showing up on the group quiz. It says, okay, so what's the y-intercept, and interpret the y-intercept. So at that point, you're going to say, okay, the y-intercept is 5.710, and that's when x is equal to 0. So what that says is it's for, for a couple who courts for 0 years, you would predict that they would be married for 5.710. Maybe that doesn't sound right. Maybe it doesn't make sense in the context of the problem, but you still write it, okay? So for, 0 years of courtship, you would predict that they would be married for 5.710 years. Okay, moving on to part D, explain what the quantity S equals 2.74982 measures in the context of the problem. S is going to be your standard deviation of your residuals. So when we're using this line to predict how many years you're going to be married from years you're courting, we'll typically be off by that amount. So we'll say we will typically be off by 2.74982 years of marriage when we're predicting. So I'm just going to leave it at that. You can add more of the context in to be more accurate by saying, when we're using the least square regression line, we'll typically be off by 2.74982. You want to say the years of marriage. It's always based on y. So let me erase all this stuff now and move on. Okay, so the psychologist is curious about whether having children has an impact on the relationship. She draws a second scatter plot with those couples who have children as open squares and couples without children as closed circles. Comment on the impact that having children has on the relationship between the length of courtship and length of marriage for these patients. So it appears from the scatter plot, since the open squares tend to all be, at the top, and then the blacks, the colored in circles all tend to be at the bottom. It appears, just looking at it, that people that had children ended up having longer courtships and longer marriages. People without children had shorter courtships and shorter marriages. So I just said, it appears that patients who have children had longer courtships and longer marriages. That's just the sentence I wrote. Okay, on to the next. So we have a new scenario. We have 1 week, and a statistician notices that some of the cars in his neighborhood are very clean and others are quite dirty. He decides to explore this phenomenon and asks 15 of his neighbors how many times they wash their cars each year and how much they paid in car repair costs last year. His results are in the table below. So we have X is the number of car washes per year. Y is the repair cost for last year. They give us the mean of X, they give us the standard deviation of X, and then they give us the mean of Y and the standard deviation of Y. The correlation of these two variables, which is R, is negative 0.71, and a scatter plot reveals a roughly linear relationship. It says find the equation of the least square regression line with Y as the response variable. As your least square regression line is also abbreviated sometimes as LSRL, so just be aware of that. It is that line of best fit. It is the line that we are finding when we run a linear regression on our calculator with the slope and the y-intercept. So don't let all these words scare you. The least square regression line is just that line of best fit. Okay, so they say find the equation of the least square regression line with y as the response variable. So in order to get this equation, we need to find the slope and we need to find the y-intercept. So you can look at your formula sheet for the AP exam, and it's going to tell you to find the slope, which remember we call B1. You just take, sorry about that. You just take R and you multiply it by the standard deviation of y over the standard deviation of x. And again, guys, that is given to you on the AP formula sheet, so you don't have to memorize that formula. Okay, so we are given an R value of negative 0.71. The standard deviation of y from the chart above is 323.5. Okay, and then the standard deviation of x is 3.78. And then you're just going to calculate that. So I plugged it in my calculator and I got negative 60.7632. And so that is our slope. Okay, that's our B1. Then we need to take that along with some other values to find the B naught, which remember that's our y-intercept. So on your formula sheet for the AP exam, it's going to have y with the bar on top of it. Remember that means the average of y, the mean of y, minus B1, which we just found to be negative 60.7632, times x bar, which is the average of the x's. So we have all that information that we need. The average of the y's, according to the chart above, is 955.30. Okay, minus our slope, which we found to be negative 60.7632. Okay, times the average of our x's that we get from the chart above, which is 6.4. Okay, so when you calculate that, like just plug it all in your calculator, you get 1,344.1845. Okay, so they asked us to actually write the equation. We want to write it in statistical symbols. So we're going to go y hat, supposed to just be an upside down V. So y hat is equal to, we want to do the constant first, the y-intercept. So we do 1344.1845. Okay, we have a negative slope, so we want to say minus the slope, 60.7632. And then times x, because you always want to attach your slope to your x. So this is the answer they were looking for. Okay, moving on. What percentage of the variation in repair costs can be explained by the number of times per year a car is washed? Your variation, your percent of variation, is always r squared. So we know that r is negative 0.71. So if we would just square that, then we would have our answer. Okay, gotta start it again. Sorry about that. Okay, so we're going to square negative 0.71 on our calculator, and you get 0.5041, but it is a percentage they're looking for, so we would say it's 50.41%. That would be the answer we're looking for. So when you see variation, you're talking about r squared. Okay, and I know that a lot of people are stressed out on how do you interpret the variation, so let me just say it again with the context of this problem. You want to say it's a percent of variation see if I can write on this. Probably not. Nope. Back to the PowerPoint. It doesn't want to let me. There it is. Let's try again. Okay. It's the percent of variation in y, whatever your y variable is accounted for by x. And so in this scenario, our x is the number of car washes, y is the repair cost. So we would say 50.41% of the variation, so let's put of there, of the variation in repair costs for last year is accounted for by the number of car washes per year. That's how you would interpret it if it asked you to interpret it. It's not asking us to do that in this problem, but I know that some of you were stressed out about that on the daily check a little bit, so I just wanted to cover it again. Okay, so plug the number in, say 50.41% of variation in, we need to say repair cost for last year is accounted for by the number of car washes per year. So for the y and x, you don't want to actually use the variables. You need to plug in the variables in the context of the problem. Okay, part C, based on these data, can we conclude? It's not asking, is there a correlation? Can we conclude that washing your car frequently will reduce repair costs? The answer is absolutely no, and it does ask you to explain. I'm not going to write it down because going to the next slide is driving me crazy, but let me just explain. So you would need to talk about, for an explanation, if this was like on your real test, other confounding variables could affect this relationship. So even though, yes, we do have, we have a correlation, we have, negative 0.71, we know there is a linear relationship between washing your car and repair costs, but what about the other confounding variables that it takes to take care of a car? Like you need to get the oil changed, you need to get the tires rotated, like you need to do other things to keep up your car besides just washing it. So taking care of, engine maintenance and things like that, that could be responsible for the association. The other thing that you might want to point out in a situation like this is this guy's just doing, the statistician, he's just doing an observational study. He's just going out in his neighborhood. Maybe everybody in his neighborhood takes care of their car, who knows? But it's an observational study. It's not an experiment. And so he does not have that cause and effect relationship proven for his observational study.